We are evaluating the effect that the hurricane had on forest in general across the island. In this particular forest, we're looking at two things. We're looking at how many trees are dead, but we're also doing a study of the different effects that the hurricane has on species. So we want to understand how do different species respond to hurricanes, how do they recover. What we've learned from past hurricanes is that the recovery can be very swift. You can have forest recovery in 5 years, you will have a closed canopy and fully developed. However, what changes is the species composition.
All of these trees were blown down by the hurricane. So what you see here, it's a lot of the architecture of the forest being modified by the event. The whole canopy was removed. And then you see a lot of woody material being deposited from the canopy into the ground. What is very evident also here is that when you open the canopy as dramatically as it is now, we have environmental conditions being changed. You have more light reaching the ground, but also a lot more water. It's kind of an interaction of the two main effects that the hurricane will have, which is the distribution of the organic material from the canopy into the ground, but also the microclimate effects that will affect the temperature and the moisture in the litter and ground layers.
This landscape, of course, has evolved to coexist with hurricanes. The species that you see here have evolved in the repeated hurricanes that happen every 30 years. And so this is normal. They have mechanisms to cope. Some of them do what the palm do. They shed all their leaves and they put them on again. Others produce a lot of seeds and they recruit new seedlings into the population. Others fall over and generate new sprouts. So every species is slightly different, and we have very little understanding of these kinds of adaptations in species. From the point of view of hurricanes, and these catastrophic events, the key issue is really what is the return interval of these disturbances relative to the lifespan of a tree, right? If you have storms that return every 20 years, the trees don't have time to grow to a size when they can reproduce, right? And so they cannot stay in the community. So this is really the key issue. And this is why understanding the return interval of severe events, whether it's fire, whether it's hurricanes, is really important.
Models project that the intensity and the frequency of these events will accelerate, will increase over the next 50 years or so. But what effects these intense hurricanes or the frequency of these events will have in the forest, we don't know yet. If these hurricanes became so intense, so close in time that the system is not allowed to recover, then potentially there might be a shift in the species composition.
Can we make forests that are resistant to hurricanes or more resistant to hurricanes? How should we build areas or restore areas that have been deforested with a specific species? And that's always a complicated question because you can't just manage for one thing. We manage for timber, for drought, for hurricanes. We manage for a lot of things.
I think this presents a tremendous learning opportunity for people in the island and all the other visitors that we get during the year. I think this is a story of resistance, resilience, adaptation, where everybody can see, observe, and learn of how these tropical forests have adapted for many years and how they can recuperate and provide these ecosystem services that we all depend on.